Kinematics in one dimension or linear motion by lettergram. Displacement is either the change in the position of an object, or in other words, the displacement of how far an object is from the starting point. Below the definition, you could obviously see that there's a graph. The red line represents an object moving 5 units to the right. Now I have added in a blue arrow pointing to the left. This represents 2 units to the left. In order to find the displacement of this object, after moving 5 units to the right and 2 units to the left, as stated in the definition, the displacement is how far from the object has moved from the starting point. So I must do 5 units to the right minus 2 units to the left. This gives me 3 units to the right, which is in the left-hand corner of your screen. Once that is understood, we will need to move into the formulas that you need for this chapter. The average speed equals the distance traveled divided by the time elapsed. Velocity equals displacement divided by time elapsed. Average velocity equals final minus initial position divided by time elapsed. Average acceleration equals change of velocity divided by time elapsed. Please note that speed refers to how far an object travels in a given time interval, while velocity, on the other hand, is used to signify both the magnitude of how far an object is moving and also the direction in which the object is moving. Now we have the equations. V with a line over it is the average velocity. Delta x is the change in distance. Delta t is the time elapsed. And a with the line over it is the average acceleration. Under that, we have 3 major equations that you're going to use in this chapter. The average velocity equals delta x divided by delta t, or change of distance, divided by time elapsed. Delta x can be broken down into x2, which is your final distance or displacement, minus the initial x1, the initial displacement, divided by t2, the time elapsed, the final time, minus t1, the time you started, which is usually 0, and x1 is usually 0 as well. The next equation is to the right of that one. A equals v minus v initial divided by t. This could also be shown as a equals v minus v naught divided by a represents acceleration, which is equal to the velocity minus the initial velocity divided by time. This equation can also be shown as a equals v divided by t when starting from a velocity of 0. Or when, let's say, starting from a velocity of 1 meter per second and going to 2 meters per second, you will go 2 minus 1 divided by the time. Below that equation, on the giant box at the bottom, we have the average acceleration equals the change in velocity divided by the change in time, or delta v divided by delta t. Delta v can be broken down into v2, or the final velocity, minus v1, or the initial velocity, divided by t2, the final time, minus t1. Now we get into more advanced equations, in which we assume that there's a constant acceleration. A equals v minus v initial divided by t, which was shown in the previous slide, is now changed into v equals v initial plus acceleration times time. For the next equation, we look at the average velocity equal to x2 minus x1 divided by delta t. In this slide, this is shown as v average equals x, the final displacement, minus x initial, which is the initial displacement, divided by time. Using basic algebra, we could determine that the final displacement is equal to x initial, displacement initial, plus the average velocity times time. The next equation shown below that is the average velocity equals v initial plus v final divided by 2. The last equation on this slide is pretty tricky. You're going to have to use the second equation from the top, x equals x initial plus average v times t. You are then going to have to set the equation equal to itself. So x initial plus average velocity times t equals x initial plus average velocity times t. In place of average velocity on one side, you're going to input v initial plus v final divided by 2 times t plus x initial is equal to x initial plus average v times t. That will give you an equation by solving through algebra, which you can do on your sheet of paper if you please. X final, the final displacement, is equal to x initial, the initial displacement, plus v initial, velocity, the initial velocity, times time, plus 1/2 acceleration times t squared. The final equation, it being the trickiest, I dedicated a whole slide to. First, you start off with acceleration equals velocity minus velocity initial divided by time. You then change that to time equals v minus v initial divided by a. Or time equals velocity final minus velocity initial divided by acceleration. You then take the equation x equals x initial plus average velocity times t, or final displacement equals displacement initial plus average velocity times time. In place of average velocity, you put velocity initial plus velocity final divided by 2, and in place of time, you put velocity minus velocity initial divided by acceleration, which, if you follow the purple arrow, then gives you x equals x initial, in little parentheses, v initial plus v final divided by 2, close parentheses, open parentheses, v final minus v initial divided by acceleration, close parentheses. Which, if you follow the greenish blue arrow down, will give you x final equals x initial plus v final squared plus v initial squared divided by 2a. If you then follow the maroon arrow, will give you v squared equals v initial squared plus 2a, open parentheses, x final minus x initial, close parentheses. Thank you for watching Kinematics in the One Dimension by Lettergram. Feel free to visit lettergram.org or lettergram.net to see the full video with example problems included.